Welcome, everyone. Welcome to Google Cloud Next 2026 and to our session, Building an AI App, a Low-Code Guide for Small Teams. My name is Rahul Deshmukh. I am a product manager for Google Cloud Databases.
My name is Gamboa. I'm the CTO of SIESA.
And my name is Yoav. I'm a product marketing manager for databases at Google Cloud. So let's look very quickly at the agenda. So what we're going to talk about today is basically, like you saw, how to build an AI app quickly. And we'll see how that connects with databases and with your own data, which is the most interesting way to build an AI app with your own data. So we'll go through a few steps that we recommend to get started. We'll do 2 demos, actually, that show an online store. And this is a situation where you have an existing app, or this is an imaginary online store. They have an app, and they want to add AI to that app in a quick way. Then we'll hear from Diego about SIESA and the journey that their company did to get to AI, and a few next steps, including a code lab that you can run that will show some of the things we're talking about today. So in terms of what you need in a small team, I mean, we keep hearing the same things, and it's not true just for databases or just for AI apps, or it's kind of true across any cloud activity. It's pretty consistent. It needs to be easy. It needs to be cheap, because AI can get expensive, as you probably all know, and it needs to be secure. So security is always an issue, and if you're a small team or a small company, you don't have a lot of, like a huge security staff, et cetera, then you are probably looking for best practices, things that you can do in a simple way where you wouldn't really go wrong too often. So that's the aspect that we'll try to show today. And there's pretty much a myth that you do need a big team, that you need specialized software. You probably know that in AI, everything is based on vectors. So you would need like a very special database with lots of processes, copying data, ETL, and all of that. And it's not really true. And the really good way to do it, as we'll talk about, is to identify a few places where your data is and to try to add AI capabilities on top of that. Maybe one more thing about that is, why are we here? So Rahul and I are both in the database team. And why are you hearing from the database guys about building an AI app? And the main reason for that is that the database is really at the heart of every application, obviously. And if you look at modern databases, and especially what's come out in the last 2-3 years, every database, basically from Google Cloud or any other vendor, has a lot of AI capabilities built in. And there's a lot of and they do a lot in order to kind of bridge the gap between AI models on one side, like Gemini or any other model, and the app or agent that you want to build. So typically, you would write the code in a very specific way so that your app has a very easy time getting data from the database, doing whatever AI processing you want to do on it, and giving the result to the user. So we'll see today how databases really help you do that, and that's kind of the quickest way to build an app based on your own data. So what we'll go in today is 4 things that we recommend for getting started. The first one is vibe coding, which I'm sure every single person in the room has at least tried or has heard of. So with vibe coding, it's pretty amazing. I mean, I was shocked when we were working on this session how much vibe coding tools can do that they couldn't do 3 months ago or 6 months ago. So we'll show some of the cutting edge capabilities in the demo. The second thing is hybrid search. So if your app has any kind of search functionality or website, a lot of database queries and things that you read from the database essentially become a search capability. And of course, at Google, we would say that, but we really believe it. So it becomes a search problem, and we'll see how you can do that and add AI capabilities to your search. The third thing is MCP servers and tools. So the MCP protocol has become a huge, huge hit in the last year or two. Actually, the guy who originally designed the protocol is speaking at one of the sessions here at Next, so you can go and check that out. So we'll talk very briefly in our session about how you can use servers and tools in order to build your app. And the last thing we recommend is to try to add some chatbot capabilities. If your app doesn't have them yet, you can create a chatbot that uses AI in a really successful way. So those are the 4 things, and we'll kind of go over them in order during this presentation, and we hope you're going to have fun. So over to you, Rahul.
Thank you. So we are going to look at, as Yoav said, we are going to look at a very simple demo. Most of you, when you think about AI, you're likely being told by your leadership that you need to introduce AI into an existing application. It's not going to be some sort of a, I want to track my calories, or I want to, build my own playlist kind of a thing. You're going to have a extremely boring, tedious, but yet crucial and revenue-generating app, and you need to find a way to AI-fy that app. So how do you go about doing that? At the end of the day, the fundamentals are still, pretty simple. So we have taken an example of a simple e-commerce website. There is a plant shop, and right now it behaves very much like a 2020 plant shop, where there is a search bar. You can do a search, but it's full text search. And there is a chatbot, but when you ask it a question, it really doesn't have any specific context about you or about the real-time data that it has access to. So we are going to show you how you can use AI and go gradually about sort of improving this application and making it a very modern AI-powered application using the tools and technologies that are at your disposal on Google Cloud. When we think about AI and when we think about agents, there are 2 ways that we should sort of frame it to ourselves how AI can help us. The first is build time, which is more of a developer assistance use case. This is where you're working on an application, you're improving an application, or even building a new application. But when the application is finally built and ready to go, the experience has nothing to do with AI. It's just satisfying some crucial business need, and there is really no reason or space there to add for example, a conversational experience to it. But in this case, you can use AI tools to actually to accelerate the process of building that app or extending the app capabilities itself. This is what we refer to as a scenario where AI helps you build the app. Then the other part of it is the runtime, which is where you are actually building an application which is going to have an agentic experience. This is where you are building an agent or building an AI experience that the end users will experience. And in this case, you have to think about the kind of problems that you will be exposed to and make sure you're looking at the solutions or the tools that will help you solve those particular problems. So Yoav talked about vibe coding, which is, again, as he said, everybody has heard of. But we have started moving from vibe coding to agentic engineering. And so when you are thinking about vibe coding in an enterprise mindset, what it really distills down to is 3 specific things. First is agentic skills. You want to make sure that when you're working with agents, that you are building skills that will empower the agent to achieve the very specific tasks using the context that is very local to your application, and you're providing it to the agent so it doesn't sort of go around the world looking for that specific information. Second is MCP servers and tools. We'll talk more about this later in the session, but this is essentially your way of telling the agent, here is an application or here is a data store that you should have access to, but I'm going to control the kind of access you have, and I'm going to control the kind of the manner in which you are going to interact with these services. But I'm giving those to you so that your knowledge goes beyond what you were essentially trained on. And then the third thing is plugins and extensions. This is where the build time use case comes into picture, where you are thinking about, if you have been writing code in VS Code, how do you then take that and sort of create an agentic experience out of it, where you're using an agent and you are giving it a prompt, and you're giving it in a way that it knows exactly what to do, and it can start optimizing on the token spend. So let's look at the first demo. Again, we are still talking about the plant shop. Now, in this case, we are going to first tackle the search experience, and we are going to make sure that the search experience improves in a way that it starts supporting semantic understanding and returns results accordingly. We are going to use Gemini, and we are going to use AlloyDB, our managed Postgres database from Google Cloud. And we are going to have Gemini interact with AlloyDB using our managed remote MCP server endpoint. We'll talk about all of these things in more detail later, but let's keep going forward. The way that the agent is going to go about it is, we will tell the agent that we want to introduce semantic search. Then the agent will go and inspect the existing database and table schema. It will recognize that it needs to add an additional column, generate embeddings, and it needs to add an index on top of that. And then it also needs to go and update the front end so that the new experience is up and running. And as a result, semantic search should start working. Let's look at the demo. So in this plant application, my plant website, if I just search for something like Monstera, I can see that it returns some, 3 results where Monstera is either in the name or in the description. But now what I want to do is, I want to look for plants that are friendly or friendly with dogs and cats. So if I search for that, plants that are friendly for dogs and cats, there are no entries here where the description specifically says either dogs or cats. However, there are quite a few entries here where it says pet friendly. There we go. So there is no semantic understanding here. The application doesn't understand that being pet friendly also means being friendly to cats and dogs, because those are some of the most common pets one can find in house. So how are we going to fix this? We are going to, so let's first look at the code itself. So I have the application. This is my existing application, and what I am going to do is I'm going to give it a prompt, and essentially in my prompt I'm going to say, currently my application has a single search bar. I would like to go from full text search to semantic search, go implement that, look at the AI-powered semantic search capabilities that AlloyDB offers, because I know that is the database my existing application already uses. And then I'm going to say, I do want to actually do some sort of an A/B testing. So don't just replace my existing search with the semantic search. Keep both so that I have some sort of a toggle to compare the behaviors. So I'm going to do that. And in the interest of time, I ran this, and I asked it to come up with a specific implementation plan, which it did. And eventually, when it implemented the plan, this is what it said. It said that it prepared the database by creating a vector column called description vector. It added embeddings to the column using the text embedding 005 model, using the AI schema. And then it created a high-performing scan-in index on top of that column. And then it also updated the the backend and the front end to make sure that it is using the semantic search. Yoav will go into more details about the AlloyDB capabilities, but let me just show you how this now looks like with the implementation in place. This is a real demo, which means that after I came here, the demo part stopped working. That's why we have a backup. So I'm going to show you the backup. So if I go over here, you can see that the end result is very similar. It is actually saying something similar, that I added some sort of a vector column, I updated the backend and the front end. And so when a search query is actually run, this might be a slightly different search query. So first of all, you can see that there is a classic and an AI mode that is now added. And the classic mode still works. When you search for Monstera, it does show those 3 results. So full text search is not broken. It still works. But now, if you search for plants harmless to dogs using classic mode, it doesn't do anything. But when you switch to AI mode, it does actually show you the results. Now, what I want to do is, if you look at the first results, it says rabbit's foot fern. I'm going to very quickly go back here. And here, I'm going to just say rabbit, so I can bring up that result. And you can see in the description, it actually doesn't say anything about cats and dogs, but it does say pet-friendly, which is the whole point of semantic search. All right, so I hope that makes sense. Let's move on to the next slide.
OK, thank you. So when I saw that demo for the first time, I was just shocked. So it didn't know how to search. It didn't know that pet-friendly and friendly to cats and dogs mean the same thing, and now it does. And we didn't write a single line of code, just with vibe coding. So it's a bit shocking. Anyway, so what did we add exactly? So at the beginning, we only had text search, right? So we could search for the name of a plant, and it worked, but it doesn't understand semantic meaning, right? So if I'm looking for large plants, it won't find them if the description says big plants, because it doesn't know that large and big mean the same thing, right? Which is what we wanted to fix. But what happens if you only have vector search? So you only have semantic AI search, but you don't have text search. Probably better if you have to only choose one. But it can still make mistakes, because you know that AI LLMs are non-deterministic. So they can give you different results at different times. And they're smart, and sometimes maybe a little bit too smart. So they will try to give you the right answer, which is maybe not what you were looking for. And what we'll see later on is how we have the capability to basically combine both of them in hybrid search, meaning both text and vector search, and it does all the work for you. So it basically combines both types of search indexes. So let's do a quick, basically just an overview. I'm sure many of you already know this, but basically what we did is, or what every AI database does, it takes the data, which can be in any format. It can be text, it can be audio, video, whatever it is. Anything can be turned into a vector, which is like vectors that we all learned in algebra. And you can store them as embeddings, meaning that you take the vector form of that data and you can store it in the database. And then you can search on it so that it can find close matches. So big and large are 2 words that mean roughly the same thing, and therefore a vector search will find that they're close to each other, and they'll give you that result because they semantically mean something similar. And the vector database simply stores all of those vectors and gives you search capabilities and can do all of those manipulations, and you can read and write vector data inside of your application. One thing that I just want to mention is that if you're looking for a vector database, there's a few from Google, there's a few from other vendors. There's a lot of good vector databases on the market. Don't forget to also make sure that it's a good database in general. So whatever vector database you use, it should also be a good database. It should have backups, it should be reliable, high availability, scalability, all of those things. So don't lose track of or lose sight of what any database really needs to give you, whichever database you choose to go with. So basically, we took the plant's information from our application, created vector embeddings, and stored those inside our AlloyDB database in this case. And basically, every vector is just like a long list of numbers. And every embedding, these are not obviously the real embeddings because the real ones would be much longer. But every plant name, every description would become an embedding that we store in our database, and then we can search on them. So if the user question is harmless for pets, the user question, we take that, we generate a vector from that, and then we search for vectors that are similar to what the user was looking for. And that's when we find a close match. 2 more things about vector search. One is, if you remember, Rahul also mentioned that when we started the search, and the first version of the application, it didn't know anything about Rahul. Like if there's any settings, like where he lives, age, whatever, like any information about the person, then it was not able to use that, and now it can, because we're combining both the structured and the unstructured part of the data. So in this example, this is just a different example. If I say color equals red, like this is what the SQL, the select statement would look like, and color equals red, that's a very traditional SQL, it's a field, it's a column in a table, and just like any database query that we've had for 50 years. But when we say text embedding harmless for pets, there we're using AI, right? This is unstructured information, it's natural language text, and we can combine them both in the same query. And I'm showing this just for fun because you don't really care what this query looks like because it was generated by vibe coding, right? So you don't even have to read it in real life, not anymore. But this is the kind of SQL statement that it would generate. The second thing we wanted to mention about hybrid search is that there's an announcement that's coming out actually this week about a function that basically uses both the text index and the vector index and does a ranking of what are the most likely results that the user is looking for. So basically, it does the ranking for you so you don't have to write any code. So until now, you kind of like, you took the phrase that the user was looking for, you did a text search, maybe it gave you 10 results, and then you did a vector search, it gave you another 10 results. Now you have 20, you're not sure in which order to put them. Like, should I prioritize the text result? Should I prioritize the vector result? Which is closer to what the user is looking for? So there's some really good algorithms that help to do that, and now that is available with a single function call, so which the vibe coding tool will, of course, go and call for you, so that it does all of the ranking for you from both of those indexes. OK, over to you. This is the third section. We'll talk about MCP and tools.
Thank you. So I think we spent enough time talking about the build time use case. I think there's probably one other thing that I wanted to show you, which is skills, which I will when we switch on to the second demo, just as a precursor. But generally speaking, what you want to do is you want to make sure that you have an agentic coding surface, which could be an IDE or a CLI. You have a model running there. You're making sure that you have added enough context, and you're giving it the ability to talk to your data store. And then you give it a prompt, and you sort of work through the prompt, make sure understand if it ends up making mistakes, and then you optimize that, add that information as a skill, and just keep going from there. So that's the way that typically the build time use cases work. But now let's talk about the runtime use case, which is more interesting, which is more agentic, which is where we are kind of heading very quickly towards. So these terms are thrown around very commonly, but when you want to really sort of piece this end to end, when you're staring at the application that has been running for so many years, and you're wondering, how do I go from here to something that just does magic? So this mental map hopefully is useful. So first we start with the application. It's your application that an end user sort of talks to, they interact with it. Now, if the application, if you give the application if you give the ability to a user to ask the application, are there any deals on this plan? You would go and build an agent using an agentic framework like Agent Development Kit or LangChain or something like that. And it would accept that function call where application is saying, the user is asking, are there any deals on this plan? Then you want to empower the agent by giving it access to tools which an MCP server hosts. And this could be tools that an MCP server hosts, or this could be skills that you have already sort of added and to your agent. But you essentially, then the agent takes that natural language sort of input, and then it converts that into, it looks around, it says that what tools do I have access to? It finds the one that matches the most closely, which in this case would be get applicable promotions, and then it would invoke that tool. Now, what the tool is actually doing, the tool is nothing but just a wrapper around an existing API for some application. So these tools, you may have built those yourself for your other applications or for your data stores, or for, as it is now true for most of the Google services and our first-party APIs, we offer these tools and endpoints just out of the box. So then the tool will essentially go and run a query on the backend database saying, select code and discount from this table where active is true, because I want to know about active promotions, not something that expired a day ago. And then it gets the result saying that there is a promotion going called Summer 20, which offers 20% discount. When the agent receives that, the tool returns that as 20% off with the code Summer 20. And when the agent is returning the response to the application, it is giving a much more natural language response, because the agent is, it's using an LLM. It will say, yes, there is a deal for 20% off with the code Summer 20, and the application sort of surfaces that to the user. This is how a mundane application starts sort of generating these magical experiences. So let's break it down just a little bit more. So tools have now become very important, very critical, and we have talked about MCP a little bit. It's very common as well. The Model Context Protocol is now sort of a universal surface for everybody to sort of, to have agents talk to different applications with different API structures. They can use MCP to have those communication. How does this actually look like for something like databases, though? So for databases, you could have tools that may be pre-built, like list tables, or give more details about these tables. Or you could have a tool like Execute SQL, where you are providing it natural language input, and it converts that into a SQL statement and runs. And this is where, when we are talking about a runtime use case, that conversion becomes a critical thing. You want that conversion to be accurate. You want that conversion to be safe. And that's where you need to sort of spend more time and make sure that you're choosing the right solutions in this case. At Google, we have, when it comes to databases, there are two primary ways that we offer Model Context Protocol support. One is our managed remote MCP servers. So these, we announced this in December, when we launched these for BigQuery and a bunch of our Google Cloud services. And I think as recently as this week, many of these services have now gone GA, including for most of our managed database services. So managed MCP servers are basically, again, endpoints, MCP endpoints for existing APIs. They offer common governance. You can treat them like any other GCP resource. You can put IAM authentication. You can put controls over which user, which org should have access to a certain endpoint. And they also offer integration with Model Armor, so you can protect yourself from prompt injection and other similar attack surfaces. And it also offers an integration with auditing, so you can actually audit who is talking to that MCP endpoint and what are they actually asking. The other solution that we offer is MCP Toolbox for databases. This is an open source MCP solution which recently went 1.0, which is a stable version. MCP Toolbox for databases is open source, which means that its support goes much beyond our first-party databases. It supports over 40 data stores, including MongoDB, Oracle, Neo4j, Snowflake, and so on. So it has received a broad adoption, and the way to sort of think about it is, if you want to do some local deployment, if you want to test something locally, or if you want it to sort of talk to multiple data solutions, which are not limited to just the first-party databases, then you can consider using that. One of the key features that MCP Toolbox for databases offers is called custom tools. With custom tools, you can sort of create a custom SQL statement, and you can say that I want the agent to invoke this specific statement, which will run exactly this SQL. And you can also add something called parameter security on top of that, where you can say that if I need to pass the user's identity to the database. For example, if I'm going to search for what sessions do I have where I'm presenting at Next, I don't want to see results for Yoav, or I shouldn't be able to pretend that I'm Yoav and sort of see the sessions that he's presenting at. For those kind of scenarios, parameter security essentially makes sure that the user's identity that the application is passing over, it goes directly to the tool, so that the agent cannot interfere in between and do some sort of an injection. So these are some really interesting capabilities which come in handy when you're talking about a production use case. All right, so very quickly, the second demo I'm going to show you. So in this case, the demo is built. I'm going to show it to you in action, and then we are going to look at a couple of code pieces to sort of explain what this demo is actually doing so that you can go and try it yourself as well. In this case, for the architecture, we are using the agent development kit. We have created an agent with ADK. It's also using MCP toolbox. There are some custom tools we have created, and it's using the AlloyDB Postgres extension, which is used for finding the if you want to like do a comparison between two locations, you can do that using SQL, using the Postgres extension. There is also a very cool feature called query data that Yoav will talk about, and we are using that as well. Let's quickly take a look at the demo. All right. So for this demo, what I'm going to do is, let me return to my application. OK. Let's say that I look at this particular plant. I like it. $125, it seems a little bit steep for a house plant. So I'm going to ask it a question. Are there any deals on this one? And you can kind of see that it is actually invoking a tool called get applicable promotions. Now, this is our choice of exposing this information to the user, but the point is that the agent invoked this tool called get applicable promotions, and it was told that yes, there are a couple of offers, and you can use either of these two. And I'm going to say, sounds great. Where can I pick it up? Now, in a real-life scenario, you would build a part in the application where you are asking the user to share the location, and you will use that and sort of tell them where they are. In this case, we have cheated a little bit. Our friend who built this demo, he lives in Paris. I'm jealous. So it's using his location, and it's essentially saying that not very far, 20 minutes drive from here. Great for him, but not for me. I live in the Bay Area, so it's I can't go to Paris to pick up a plant. So I'm going to say that's not good enough for me. So can you just deliver it instead? Okay. It's saying, yeah, I can deliver, and through some magic, the plant can just show up from Paris to here by tomorrow morning. I'll just pick that slot. I have asked the agent to ask for a confirmation that do I really want to do the pickup and to confirm the booking, which I'm going to say yes. And it says the order is confirmed. Now, very quickly, what does this actually look like under the hood? So for this one, what we are going to quickly look at is, first, I want to show you, save. Okay. So very quickly, I mentioned skills a few times. Again, like a demo is a sleight of hand, but when you're doing it real world, this is where the ugliness sort of happens. So this is where you are actually, but this is not something that you need to write from scratch. That is the whole point of vibe coding. You ask the agent to do certain things. It may get them wrong the first time, but you can ask it to say, can you give me what should I add to my skill so that you won't make these mistakes again? And you can just take that part, add it to your skill, and just try it again, and that's how it just keeps getting better. So in this case, I have this plant expert, which is my agent that have been created using ADK. And there I'm saying, this is the prompt. I'm telling that you are a shop assistant. Make sure your responses are curt. And these are the capabilities that you have access to. And all of these are custom tools that, some of these are custom tools with MCP toolbox. But we also have a feature called query data, which you all will talk about. We also are saying that for questions that may go beyond what we specifically are offering with custom tools, you can use this new feature called query data, which accepts a broader range of questions that you can answer. I think the only nuance I'll give you and hand it over is that you want to make sure that you divide into questions that the agent, the data access that the agent should be able to do without any supervision, and the one that the agent should be able to do in a strict, predictable manner. That's where you make a switch. Let's head back to the slides so that we can talk more about query data.
Okay, thank you. And by the way, our friend in Paris, what he told us is that when he tried it the first time, he went to the vibe coding tool, he entered a prompt, and it was about 50%, it did about 50% of what he wanted before he knew how to prompt. And then with practice, he changed the prompt again and again and again, and he got to about 100%. So same advice for everyone, practice your prompting in your vibe coding tool, and if it does half of what you want right from the start, that's not too bad, and you just have to practice. Okay, so a few more words about natural language. So like Rahul mentioned, the new query data tool, you'll probably hear about it in several sessions during this week, both in the small IT track and in other databases and analytics sessions. So basically, this is a tool and an API where you can basically give a natural language, English language or French or any language, and it generates a database query to match what you said in the prompt. So if you, in the text. So if you ask the question, how much money did I spend yesterday? That's a natural language question in English. And then it goes and generates, it sees yesterday, so it says date equals April 21st, 2026, and it creates a SQL query that will correspond to that. And it has a lot of tricks that it knows how to do to look at your database and understand the context. And what we want you to take away is, first of all, that it's accurate because it does hill climbing. I don't know how many of you have heard this term, but hill climbing is basically a fancy way of saying that the natural language interface, that this query data API will go and try again and again and increase the amount of context that it looks at and what is in your database and what other information it can pull, and to climb the hill to 100% accuracy. So it'll even do that in iterations even without your intervention until the API is happy or until you're happy with the result. Second thing, which we briefly talked about, is security. So parameterized secure views, that means that I can pass the identity of the person who is asking the question. We can pass that along so that it will only give information that that specific user is allowed to see. So if I go and say, oh, show me all of Rahul's medical records, it's not going to let me do that. So there's an important lesson there that if you're doing an AI project, don't just take all of your corporate data, put it in one place, and put AI on top of it, because then anybody can look at anything, right? So you need to separate this according to the people's roles and what they're allowed to see and what they're not allowed to see. Okay, and it's available as an API or, of course, as a tool on an MCP server, like everything else. So let me end with just, before we transfer it over to Diego, is just to say that in terms of the architecture, you'll see that the two core things we showed in the demo today are based on tools running on MCP servers. Any of you who's been in the industry for a while, you know that this idea has come in and out of fashion. So once in the past, your application used to call your database directly. And then we added a middle layer, and then we took it out, and then we added it back. It's gone in and out of fashion so many times, now it's back in fashion. And it's called an MCP server. So that's how your application calls the server calls the database. That's kind of the popular way of doing it now. And then you see the database on the right, and everything goes through those tools that we put on the MCP servers. Okay, and with that, over to you.
Thanks. So, raise your hand, how many of you have that legacy product that has been there for 10 years, 20 years, or more? And how many of that software does the payroll, the inventory, and the billing for more than 10,000 companies? That's my Monday morning. So we are SIESA. We are empowering the business across Latin America. We are one of the biggest software enterprises in Colombia. We have more than 11,000 clients. We have been in the business for 45 years. We are in 8 countries in Latin America, and we are in the top industries in Colombia. We are not just an ERP, we also are POS. We have a PMS for hotels, for clubs, restaurants, manufacturing, retail, healthcare, you name it, we have it. So we have right now a big challenge that is the monolith. We have a monolith that has been in the company for 30 years and is in the market right now for more than 11,000 clients. So we have limits here, and the limit is that there's a single code base. If you want to scale something, you have to scale everything. If you want to upgrade something, you need to upgrade everything. Also, we have an innovation bottleneck. Teams are blocked by the shared code base, and new features that should take weeks are taking months. And we have the market pressure. There are ERPs that are cloud native. The clients are demanding for a modern UX and the need of AI capabilities right now, actually for yesterday. So the challenge here is not just to change the monolith to microservices. There are plenty of playbooks about that in the market. We are talking about how you modernize all the logic that we have from 40 years. All that knowledge needs to be rewritten and we need to use it. So we make with a solution, and the solution is a code harvesting agent. That agent runs all the code that we have right now and document it, and we store it so we can use it to create the new modules that we are doing. But we didn't stop there. We also create a framework that is the SIESA agent framework that helps us to build, architect, code, test, deploy, and the developers stopped writing code line by line, and they just became experts who guide the AI to do what we need right now. So this is one of our first products that is 100% made with the SIESA agents. Everything was done from scratch using the harvested knowledge that we collect from before. And here we are using AI not just to do a chatbot, it's to chat with your data in real time and getting all the information that we have from our databases. So simple microservices, actually SIESA is one big company, and we slice it in 12 small companies. Each one is in charge of a module. We also use AP Gateway to get the governance of everything that is getting into our system. We need the governance, we need to do rate limits and monitor everything. And also we have a shared services that are the authentication, the login, and everything, because we need like a standard. And also we have our data layer that is Cloud SQL, AlloyDB, and we have synchronized all the data with Event-Sync modules. The architecture is that we are not just like front-end, back-end, and database. We are using like a really big structure. We have 11 Cloud Run microservices, 19 PubSub topics, 9 Postgres database, and we are using Vertex AI, and everything is not with infrastructure as a code. So if a developer needs something from the cloud, he just write the code, and in minutes we have it. And what we are doing now is we have that product running on SQL, we have memory storage, Redis, etc. And what we are going to do next, and that's what it comes with the MCPs. We are storing all that data with the RAG and a vector database, so we can build an MCP that the agent just don't answer questions, they actually do things. So if you need a database or if you need a change in the database, you just ask the MCP, hey, I need this change. So this is what we are working right now, and what is next? What is the vision that we have from here? And is the hyper-automation. What we need is to integrate all the things that we have, the knowledge, the MCPs, and we want to give the client the ability to build what he needs. So do you remember the SDK? So we are building an agent that builds everything. So we are not just we are not doing agents that assist our teams. We are actually multiplying our teams. That's what we want to do.